Welcome to the Deep Dive, the show where we grab a whole stack of sources, try to filter out all the noise, and just hand you the pure, unadulterated nuggets of knowledge.
hmm
You've probably been there, right?
hmm
I mean, staring at some really complex code, or maybe trying to wrap your head around a completely new programming paradigm, and suddenly you feel like you're just drowning in
Yeah.
jargon.
Oh, absolutely.
Yeah.
Happens all the time.
Yeah, terms like imperative and declarative get tossed around constantly, but what do they really mean? And maybe more importantly, why does it feel like, everyone has a slightly different definition, sometimes even conflicting ones?
It's such a common experience, yeah.
Hmm.
And if you felt that kind of definitional drift, that sense that the meaning is shifting under your feet, you are definitely not alone.
Right.
It's almost like we're all using the same dictionary, but maybe speaking entirely different dialects uh, of programming language. And that ambiguity, that lack of clarity, it can be incredibly frustrating. It can even lead to real misunderstandings in development teams.
Absolutely. And that confusion, it isn't just like an academic nitpick, is it? It directly impacts how we design, how we build software.
It really does.
So today, we're taking a deep dive into the fascinating and, yeah, sometimes frustrating history of one of the most fundamental concepts in computer science, imperative programming.
Mm-hmm.
Our mission for this deep dive is pretty straightforward.
Uh-huh.
Cut through decades of accumulated jargon, try to pinpoint the precise original meaning of imperative, and show you exactly why having that clarity matters more than ever in today's, well, incredibly complex software world.
And for this journey, we've really pulled together quite an extensive library. We're talking decades of foundational computer science papers, meticulous academic discussions, even digging into modern web conversations and forum threads, stretching all the way from the pioneering days, the early 1950s, right up to sources from 2025.
Wow, quite the span.
Yeah, we'll explore how the early giants of the field defined imperative with actually remarkable precision back then. We'll trace how that meaning slowly shifted, got diluted over time, and try to figure out where we stand today with our understanding.
Okay, so prepare for some hopefully profound insights that might just reframe how you think about the lines of code you look at every single day. You might just find yourself saying, aha, so that's what they meant all along.
Let's hope so.
All right, let's unpack this. Okay, let's cast our minds back, way back to the dawn of computing. Imagine yourself maybe in the 1950s. You're surrounded by these colossal mainframe computers, right? These behemoths of vacuum tubes and punch cards.
Yeah, room-sized machines.
Exactly. And you're trying to figure out how to tell this revolutionary new machine quite literally what to do, step by a painstaking step. What language do you even begin to use?
It's a fundamental question they faced.
Turns out the pioneers of computer science, they didn't invent a wholly new vocabulary out of thin air. They borrowed directly, and actually quite brilliantly, from something very familiar, English grammar.
Which is really fascinating when you stop and think about it. What's truly striking here is how intentionally, how precisely they used the term imperative. It wasn't some abstract, fuzzy concept they just conjured up.
No.
No, it meant exactly what it means in everyday English. Expressive of a command.
Okay.
Think about it, right? When
Yeah.
you tell someone, close the door,
Uh-huh.
or run faster, you're using the imperative mood in grammar. You're issuing a direct order,
Yeah.
a command.
Right, you're telling someone to do something.
Precisely. The early computer scientists applied this exact same linguistic rigor to their new machine languages. They saw it as giving commands to the computer.
So they weren't just thinking of code as like a sequence of instructions. They were literally thinking of it as commands, like a new kind of conversation almost with a machine.
That's a great way to put it, yeah. They were absolutely conceiving of it that way. Can you give us some specific examples, like from those foundational papers? How did they actually articulate this in their definition?
Absolutely. There's a landmark paper from 1957 that practically laid down the law on this. It stated, and this is almost a direct quote, "A set of verbs in the imperative mood provides a suitable collection of commands for the language."
Wow, verbs in the imperative mood. Very explicit.
Incredibly explicit. They genuinely saw code as actual sentences. For them, the verbs are the order types, meaning the operations or commands, and whose nouns are constants and variables, the data being acted upon.
So data were nouns, operations were verbs.
Exactly. This highlights their incredibly foundational understanding. They weren't just stringing together low-level machine operations like you might think. They were consciously building languages for machines, mirroring the structure and, crucially, the intent of human communication. They were creating syntax and semantics from the ground up, using grammar as their guide. That's such a powerful idea. It wasn't just about getting the machine to calculate something. It was about building a comprehensible, a structured new form of communication, a grammar for computation itself.
Precisely. And they even used the words sentences and statements pretty much interchangeably back then. They were explicitly acknowledging that they were constructing these linguistic structures. And, for these early pioneers, the vast majority of code was imperative. Almost everything was a command.
Even things we might not think of as commands today, like conditionals.
Right. Even constructs that might seem different to us now, like conditional if statements, were deeply rooted in this command and control paradigm. They viewed an if statement as, get this, an interrogative sentence, basically, a question followed by imperatives for the alternatives.
Okay, so is X true? If yes, do this. If no, do that. The do this and do that are the imperatives.
Exactly. So even the branching logic, the decision-making, was seen as a question that led directly to commands that would then be executed based on the answer. The command was still central.
And within this framework, this world of commands, they also had distinct categories, didn't they? Not all imperatives were just lumped together.
That's correct. They were quite meticulous about this. They generally divided imperative statements into two main classes. The first class encompassed what they called assignment statements and procedure calls.
Okay, like setting a variable's value or running a function.
Exactly. These were seen as the core computational instructions, especially in early high-level languages like algeol. Think of something like x, y plus z. That's a direct command. Assign the result of y plus z to x. Or call print report. That's a command to execute a specific procedure named print report. These were the real workhorses, performing the actual data manipulation, the calculations.
Got it. And the second class?
The second class they defined were the control statements. Now, this included constructs like conditional statements, the ifs we just talked about, go-to statements, for loops, compound statements, like blocks of code, and even things called dummy statements, which basically did nothing but could act as placeholders.
Okay, so what was the purpose of these?
These, they noted, were specifically used to direct or mark the path of computation, to define loops, and to determine the scope of other control statements. They were essentially the traffic cops of the program.
Traffic cops, I like that.
Yeah, they were explicitly directing where the computer should go next in the sequence of instructions or how many times it should repeat a certain action. They controlled the flow.
So when they said direct or mark the path of computation, they were literally talking about guiding the computer's execution pointer step by step through the code.
Absolutely, literally.
Yeah. That really underscores this direct control mindset. It wasn't just a metaphor back then. It was the lived reality of programming on those early mainframes where you had and maybe needed such granular access.
Indeed. This whole idea of absolute direct control over the program's processing state, over exactly what happened when, was utterly central to their thinking. You see it reflected in some pretty stark statements from the era, like one paper just flatly saying, otherwise all the sentences are imperative. Meaning, unless it was one of those interrogative if questions, it was a command. This wasn't just theoretical musing, it was their everyday reality. They were working with mainframes, these massive, isolated, static environments. They often had to account for every single clock cycle, every memory access. They could and often had to control the step-by-step execution in minute detail.
And even go-to statements fit into this because they feel so chaotic to us now.
Right, go-to statements, which, often feel unstructured or chaotic to us today, were a perfectly logical part of this direct, granular control mindset for them. It was just another command, go execute the instruction at that label. Simple, direct. The precision of usage for the word imperative was incredibly measured at 100% in the 1957-1961 period, according to our sources.
100%.
They knew exactly what they were saying when they used that word, no ambiguity.
It paints such a clear picture of that early world. Computation as a very literal sequential march of commands, dictated by the programmer. Okay, so here's where it starts to get really interesting. You'd think that having that precise, direct, step-by-step control, even with tools like GoTo, would be the ideal scenario, right? Maximum power for the programmer.
You might think so, yeah.
But as programs inevitably grew larger and more complex, that very directness started to become a significant problem. It led to code that was hard to follow, hard to debug.
The infamous spaghetti code.
Exactly. So in the early 70s, a quiet revolution began brewing, led by some truly visionary figures like Edsger Dijkstra and Donald Knuth. They started seriously questioning the Wild West of unrestricted go-to statements and the potential chaos it could bring. What prompted this shift? What was
Uh,
the critical problem they were trying to solve?
Well, what's truly critical here, I think, is that this period marks a fundamental mindset shift in computer science. It wasn't just about one instruction. Dijkstra's seminal work, especially his famous structured programming book from 1972, wasn't just about advocating for, say, replacing goto with while loops. It was much deeper. It was fundamentally concerned with intellectual manageability.
Intellectual manageability.
Yeah, how can a human programmer actually understand and reason about a large, complex program? And perhaps even more profoundly, Dijkstra was focused on closing the conceptual gap, as he called it, between static program text and dynamic computation.
Okay, explain that gap. What does that mean?
Think of it this way. You're looking at a static piece of code on a page or a screen. It's just text, a set of instructions frozen in time. But the actual computation, when the program runs, is this incredibly dynamic, evolving process. It's a whirlwind of changing states, data flowing, conditions being met or not met. How do you, as a human programmer, reliably connect that fixed text you wrote with the fluid live execution that happens later, especially if the execution path jumps all over the place unpredictably?
Ah, okay. So the overarching goal was to make the code on the page somehow reflect the actual logical flow of the program in a clearer way, making it easier for our human brains to grasp without having to mentally simulate every single possible jump and twist.
Exactly, that's the core idea. Dijkstra forcefully argued that the program text itself should directly mirror the computation's inherent structure. He championed using just three fundamental logical decompositions: concatenation, basically doing step A, then step B; selection of the familiar of X, then do A, else do B; and repetition, doing action A while or until some condition C is met.
The building blocks of structured programming.
The absolute building blocks. The whole point was to be able to make sound, logical assertions about what a piece of code does just by reading the text, rather than having to laboriously trace these potentially chaotic, spaghetti-like execution paths, which was often the reality with go-to-heavy programs.
Right.
This meant containing sub-actions within clear blocks, like if blocks or while loops, so they could be understood as single, coherent things, or logical units, or modules. Instead of that line-by-line mental execution, you could look at an entire for loop or an if-else block and grasp it as a single unit of logic. This directly addressed the looming software crisis that people were starting to talk about. Programs were simply becoming too large and intricate to reliably understand and maintain using the old methods.
And Donald Knuth, another giant in the field, he also had some incredibly profound insights around this time, didn't he? Almost foreseeing the kind of linguistic confusion we're talking about today.
Oh, absolutely. Knuth, in a particularly insightful 1974 paper, made an observation that feels incredibly prophetic now. He said, the language in which we express our ideas has a strong influence on our thought processes.
That's powerful.
It really is. It's a profoundly powerful idea, not just for programming, but really for any field. How we talk about code, the very words, the structures, the constructs we use, it shapes how we think about it, how we design it, and ultimately how we write it.
So the language isn't just a tool, it shapes the user of the tool.
Precisely. Knuth also directly pointed to the growing software crisis, noting that programs were becoming unmanageable due to sheer complexity. And to help with this, he even advocated for a subtle linguistic shift, making go-to labels, the destinations of the jumps, sound more like events rather than commands.
Interesting. Why?
He was trying to nudge programmers away from thinking of them as explicit "go there now" orders, and more towards thinking of them as representing abstract points or states in a process. A shift in perspective aided by a shift in language.
It sounds like they were very consciously trying to evolve the language of programming itself to make it better suited for the growing complexity of the problems they were tackling.
Definitely.
But okay, even with this powerful push for structured thinking, for better ways to express logic, some old linguistic habits died hard, didn't they? You mentioned the idea of control structures becoming ingrained, even for things like loops and conditionals. That feels like a bit of a contradiction if the goal was maybe less direct control and more logical structure.
Yeah, that really raises a truly important question, and it's central to the dilution we're tracing. Despite this clear move towards clearer, more intellectually manageable structures, why did terms like control structure or flow control persist for fundamental constructs like loops and conditionals, if switch?
Why indeed?
Our sources make it quite clear. It's a direct vestige, a leftover of that early go-to mindset. In that first era, Programmers felt they were literally controlling the process, dictating every jump, every state change, every sequence point.
Right, the traffic cop idea.
Exactly. So even as structured programming offered these more abstract, higher-level ways to express iteration or selection, the terminology itself clung stubbornly to the older, lower-level idea of control. Programmers were still thinking and talking in terms of controlling the flow of execution, rather than perhaps expressing a logical structure that the underlying process then reacts to or follows. It's a subtle but really significant difference in perspective.
So even as they built these more sensible, more abstract structures, they still described them using language that harked back to the older idea of direct, almost manual, step-by-step control. This sounds like the very first crack appearing in that originally precise definition of imperative.
And precisely.
Yeah.
That's exactly where the blurring begins, and we see evidence of this. The very first paper we found, using the broad phrase imperative language, appeared in 1972. Now, it was uncited at the time and didn't immediately gain widespread traction, but it was there.
The first
The first sighting. But then, by 1977, in the highly influential paper about the lucid language, the word imperative was actually put inside quotation marks when referring to an imperative language.
scare quotes. Always telling.
Very telling, right? It signals that it was either still considered a kind of nascent colloquialism, maybe not quite formal terminology yet, or perhaps that the authors themselves felt a degree of unease, maybe some discomfort, using such a broad and potentially imprecise term to label an entire language. It was a subtle, formal acknowledgement that the meaning was already blurring, moving away from its strict grammatical root of just meaning command.
A bit of an early warning signal then, maybe a academic raised eyebrow.
Yeah, indeed.
Yeah.
A definite yellow flag. And while some papers, even in the 70s, still used imperative with its original precision, for instance, one 1972 paper talks clearly about imperative features such as jumps and assignment, keeping it specific to commands. The broader notion of an imperative language as a category started to become a known concept by the end of the decade, even if its precise meaning was already losing its sharp edges. And this source material explicitly notes how the word control, when used to describe the program execution process state, became pervasive jargon. It calls it a vestige of an early imperative go-to programming mindset, and argues, somewhat provocatively perhaps, that the term control in that context should have been dropped in 1972 with the rise of structured programming.
Wow, that's a strong claim.
It is, but it highlights the point. This period really showcases the tension between these groundbreaking conceptual shifts in how to structure programs and the powerful inertia of existing vocabulary. It shows how language, once it's established, can continue to shape our thinking long after the underlying concepts have evolved.
It's almost like, yeah, trying to drive a modern electric car but still thinking in terms of rims and horseshoes. The old language just doesn't quite fit the new reality.
That's a perfect analogy.
Okay, so if the 70s saw those first subtle cracks appearing in the precision of imperative, the 1980s, according to our sources, were when the meaning really, well, you said it earlier, fell off a cliff.
It really did seem to plummet, yeah.
It just plunged into this realm of broad generalities. What happened during this decade? What caused such a drastic, almost cataclysmic shift away from that original clarity?
Well, what's truly striking here, looking at the data compiled from our sources, is the incredibly sharp decline in precise usage. We're talking about a measured drop from over 60% precision in the late 70s down to as low as 22% by the end of the 80s.
Wow, that's a huge drop.
It's massive. Imperative basically stopped being about specific commands, those direct linguistic orders like assign this or call that, and started being used as this kind of vague catch-all phrase to describe entire languages or even broad programming paradigms in an incredibly fuzzy and often unhelpful way.
So it lost its sharpness.
Completely. Terms like imperative language became routine, used almost casually, even if the underlying definition was totally blurry or inconsistent. For instance, we found a 1983 paper talking about the imperative nature of the editor specification. Now, while you can maybe guess what they meant in context, perhaps referring to step-by-step instructions in the spec, it undeniably broadens the term imperative, far beyond its original precise meaning of a command in code.
Right, applying it to a specification document, not the code itself.
Exactly.
Yeah.
And this is also the decade where C++ arrived on the scene, right, around 1985. And object-oriented programming, OOP, really started gaining serious traction, promising this whole new way of structuring code around objects and messages. How did that play into this growing confusion around imperative?
That's a really crucial inflection point. The introduction of C++ and the rapid rise of OOP definitely complicated things immensely because OOP, with its focus on encapsulation, objects sending messages to each other, inheritance, it often looked very different on the surface from traditional procedural programming like C or Pascal.
It felt like a different beast.
It felt different. And this superficial difference led many people to mistakenly believe that OOP wasn't really imperative in the same way, even though it demonstrably contained and often revolved around fundamentally imperative elements. Objects still had methods, right? And those methods performed commands. They explicitly changed the object's internal state. They directly told the computer what to do next.
But the packaging was different.
The packaging was different, the structure was different, and that led to this conceptual misattribution. And this, our sources argue, directly led to the appearance of what they aptly call nonsensical jargon.
Okay, nonsensical jargon sounds pretty bad. Give me a concrete example. What kind of nonsensical terms are we talking about?
Oh, it was a bit of a mess. We began seeing these truly absurd terms like imperative arrays appearing in academic papers as early as 1989. Imperative arrays, what does that even mean?
Exactly. Think about that for a second. An array is a data structure, right? It's a collection of data elements, a container. It doesn't do anything by itself. It just holds things. So to call an array imperative is completely illogical. It's like calling a noun a verb or calling a container an action.
How could that happen?
Well, the source suggests this happened because people, having lost the original precise grammatical definition of imperative as a command, started defining it backwards, essentially. They started defining imperative by looking at what languages commonly labeled as imperative languages contain.
Guilt by association almost.
Kind of. If a language like C or Pascal, which everyone was now calling an imperative language, happened to have arrays, which they did, then by this faulty backwards logic, arrays themselves must somehow be imperative. It was a classic logical fallacy, a really severe symptom of linguistic sloppiness and the loss of the original meaning.
Okay, so this is also the period where that broad functional versus imperative debate really solidified, often creating this kind of false dichotomy, almost a tribalistic divide between programming styles.
Exactly. That debate became a dominant narrative in the 80s. You'd see papers and discussions constantly pitting functional programs against imperative ones. For instance, one from 1984 argued functional programs are easier to write compared to imperative ones, but without ever clearly defining what imperative actually meant in this broad, sweeping context.
So it just became the other guys.
Pretty much. It further cemented this vague, generalized usage. Imperative became little more than a shorthand, a placeholder for not functional, or maybe the traditional way. It completely masked the underlying imperative operations, the actual commands that even functional programming often relies on at some level, especially for things like I/O.
So, okay, if the precise grammatical definition was lost in the fog, what did people cling to instead? It seems like this is when the what versus how distinction really took hold, becoming the simplified, almost intuitive rule of thumb that many of us probably learned.
Yes, this really raises that important question again. With the original meaning obscured, people needed something to grasp onto. And the idea of declarative is telling the computer what you want versus imperative is telling the computer how to do it has a certain intuitive appeal.
Right.
It feels simple.
It does seem straightforward.
It does, but as a definition, it proved to be inadequate and often deeply misleading. It was really just a symptom of the lost precision. Instead of defining imperative as a direct command, do this, it became vaguely equated with detailing how a process occurs, the step-by-step sequence.
Right.
Now, there were exceptions. Peter Wegner in 1990 offered what was, for that era, a rare and more precise definition. He said, imperative paradigms view a program as a sequence of state transition commands that progressively transform an initial into a final state, which is pretty good.
Yeah, that sounds closer. State transition commands.
It's much closer. But notice, even this definition, while better, still framed the entire program or the entire paradigm as imperative, rather than focusing on the atomic commands within the program. The granularity was still off.
And so the general discussion shifted away from the action of commanding towards the consequences of those commands, namely side effects and mutable state.
Yes, that was the major conceptual slippage. The general trend was to apply the label imperative to languages, paradigms, or operations that dealt heavily with side effects and mutable state. We see this clearly in papers from 1984 and 1986.
Okay, let's quickly define those again just for clarity.
Sure. So a side effect happens when a function or command does something that changes the state outside its own local scope, like modifying a global variable, writing data to a file, updating something on the screen.
Something observable happens beyond just returning a value.
Exactly. And mutable state
Mm-hmm.
refers to data that can be changed after it's been created. Think of a variable you can update, or an object whose properties can be modified. This is opposed to immutable state, where once data is created, it can never change.
Got it.
Now, while side effects and mutable state are certainly consequences of imperative commands, changing state is inherently what commands do. They aren't the definition of imperative itself. The command is the cause. The state change is the effect. But in the 80s, people started confusing the effect with the cause. This conceptual flippage meant the true, precise meaning of imperative as a command was increasingly obscured by its effects. It was like a diagnostic symptom being mistaken for the underlying disease.
Yeah, it's like defining fire only by saying it produces smoke and heat instead of defining it by the process of combustion. You're describing outcomes, not the fundamental action.
That's a great analogy. You're focusing on the results, not the mechanism. And that's what happened to imperative in the 80s.
Okay, so as we sailed out of the 80s and into the 90s and then the 2000s, the programming landscape just kept getting more complex, didn't it? It became this increasingly intricate mosaic of paradigms all mixed together. You had the continued rise of C++, Sen, you had Java establishing its dominance, and then later the explosive growth of JavaScript on the web. All of these languages were blending different styles.
Absolutely. The era of pure single paradigm languages was largely over for the mainstream.
Right. This must have just exponentially compounded the confusion around terms like imperative, rendering those already vague definitions from the 80s even less helpful, maybe even counterproductive.
Indeed. Our sources vividly point out that a critical mass of clearly hybrid or multi-paradigm languages emerged right around 1995. Think C++, Java, Python, JavaScript.
Yeah.
They all mix procedural, object-oriented, and sometimes even functional features.
Yeah, you could write different styles in the same language.
Exactly. And this meant that simply trying to classify an entire language as purely imperative or purely declarative was no longer sufficient, or even really accurate in most cases. Developers desperately needed finer-grained distinctions to actually reason about the different parts of their code, but the existing diluted vocabulary was completely failing them. It just didn't offer the necessary nuance.
And it's argued, interestingly, that even functional programming purists might have inadvertently contributed to this dilution.
Yeah, it's a subtle point, but the argument is that by broadly contrasting the functional style with the imperative style, often without focusing on the precise grammatical meaning of imperative as a command, they might have unintentionally reinforced the idea that imperative was just everything that isn't purely functional.
So again, defining it by what it's not rather than what it is.
Exactly. Treating imperative as merely the opposite of functional rather than as a specific type of linguistic action, a command that can actually appear within different paradigms, even functional ones in controlled ways.
And speaking of functional languages, even ones considered purely functional started showing these cracks, right? You mentioned Haskell earlier, which is often held up as the gold standard of pure functional programming.
Absolutely. It's a fascinating case. Even a language like Haskell, designed with mathematical purity and avoidance of side effects at its core, was noted in papers from 1993 and 1997 to have an unavoidable imperative feel when dealing with real-world interactions, specifically input-output I/O operations.
How so? How can something pure have an imperative feel?
Well, for instance, a 1997 paper about Haskell explicitly stated that while pure expressions are evaluated without side effects, they ultimately yield concurrent imperative computations, which are executed to perform the implied side effects.
Okay, imperative computations.
Right there in black and white. The source material highlights that this imperative feel isn't just a stylistic preference or some kind of illusion. It is, in fact, literally imperative at the point of execution. This is where things like monads come into play in Haskell. Monads provide a very clever, structured, disciplined way within a functional language to manage sequences of operations, especially those that must involve side effects, like reading a file or printing to the console.
So they package up the commands.
Essentially, yes. You can think of monadic I/O actions in Haskell as descriptions of commands or maybe delayed commands that are packaged up in a pure way. But when those packages are finally unwrapped and executed by the runtime system, they perform direct imperative actions on the outside world. They command the system. So even in the purest functional context, the imperative core inevitably surfaces when you need to interact with the real, messy, stateful world outside the program.
That's really interesting. The imperative nature is almost inescapable when you hit reality.
It seems to be, yeah. And then, of course, the internet exploded. And with it, JavaScript, which rapidly became the de facto lingua franca of the web. That must have introduced a whole new level of complexity and potential confusion for literally millions of developers who suddenly found themselves grappling with multi-paradigm code and, crucially, asynchronous operations.
Oh, asynchronous programming. Yeah, that changes things.
Completely. The meteoric rise of the internet and JavaScript's utter dominance, especially after Adobe abandoned Flash around 2011, brought asynchronous programming, dealing with things that happen out of order, like network requests or user clicks and multi-paradigm complexity directly to the forefront. And this wasn't just for computer science academics anymore. This was for millions of everyday web developers. They were now encountering these hybrid realities in their daily work, trying to make sense of event loops, callbacks, promises, async await,
Yeah, all that stuff.
all that stuff. And this asynchronous nature inherently challenges that neat, sequential, top-to-bottom how-to mindset, often associated with traditional imperative programming, even though the underlying operations being triggered asynchronously, like updating the DOM, are still very much commands.
Right. So with all these hybrid languages blending paradigms and these asynchronous operations making execution order unpredictable, that old simple what versus how rule of thumb must have started to really break down. You can't just say imperative is how to and the how isn't the simple sequence anymore, and commands are flying in from all over the place asynchronously, triggered by user actions or network responses at any moment.
Absolutely. It became painfully obvious. The what versus how distinction, while maybe a useful starting heuristic in simpler times, proved to be, as one source puts it, entirely inadequate in highly asynchronous and interactive modern applications.
Why inadequate?
Well, consider this. An imperative update, which is fundamentally a command to change some state, maybe update what's shown on the screen, can come from anywhere at any time in a modern web app. It's not necessarily part of a neat, sequential how-to list that executes predictably from top to bottom.
Right, it could be a user clicking a button.
Exactly. Or a network response finally arriving after a delay, or a timer firing off an update. These are all imperative commands triggering state changes, but they don't fit the simple sequential how-to model. This disconnect between the simple heuristic and the complex reality caused, according to our sources and lots of online discussions from the time, intense confusion and frustration for developers. They were trying to organize their increasingly complex code bases and debug tricky asynchronous issues, and the vocabulary they had just wasn't precise enough. You could see it reflected in countless Stack Overflow questions around 2014.
I remember seeing those people genuinely puzzled, asking, is this piece of JavaScript declarative or imperative? It feels like it's doing both.
Exactly that. Developers were really struggling to make sense of the code they were writing, using the very conceptual tools and vocabulary they had been given, which were no longer fit for purpose.
So the tools were failing them.
Pretty much. Many resources from this period, the 2000s into the 2010s, reflect this struggle. They often offer these really vague definitions that conflate imperative with just being detailed or maybe sequential, rather than sticking to its true core meaning as command. However, there were some glimmers of hope, signs that people were starting to grope back towards clarity.
Like what?
For instance, the term manipulation, like DOM manipulation, appeared frequently in documentation for frameworks like AngularJS around 2012. Manipulation clearly hints at the idea of direct action, of changing something.
Yeah, that's closer.
And then an excellent phrase from a 2013 source spoke of imperative code as involving changing bits, bytes, and words in memory. It's very concrete, and it clearly describes the effect of imperative commands at a low level. So these got closer to the essence, but they still maybe lacked that explicit grammatical precision of command. It arguably took a particularly insightful observation from 2017 to really hone in on it again. Someone noted, if semantics are like imperative code written in Bash, it's imperative code.
Connecting it back to the command line.
Exactly. Drawing that parallel to a command line interpreter like Bash, where you type explicit commands and things happen, started bringing the understanding back full circle, back to the core concept of direct action and telling the computer what to do right now.
Okay, so it really feels like we might be finally coming full circle here. After decades of that dilution, that drift, that confusion, are developers and academics starting to consciously reclaim the original precise meaning of imperative? Is there a tangible pushback happening against all that historical blurring we've been talking about?
There's definitely a hopeful trend emerging, yeah. And it's actually very encouraging to see in the more recent literature and discussions. Our most recent sources, looking at material from 2020 right up to 2025, show a noticeable increase in instances where authors connect imperative directly back to commands or to state manipulation, or sometimes even explicitly refer back to its original imperative mood, grammatical origins.
So a return to the roots.
It feels like it. It's like a quiet resurgence of maybe common sense or perhaps just a demand for clarity in the face of decades of increasingly problematic and unhelpful jargon.
Yeah.
People seem to be intuitively gravitating back towards what the term originally and most usefully meant.
Can you give us some specific examples of this renewed clarity? What kind of language are we seeing now that reflects this reclarification?
Sure, you'll find phrases in recent writings like imperative programming, includes commands for the computer to perform. Very direct, using the word commands. Or definitions like statements that change a program's state, which explicitly links imperative actions to their consequence, state change, but correctly identifies the statement, the command, as the imperative part.
Not confusing the action with the result.
Exactly. Another good one is seeing it described as using explicit instructions that give precise control, emphasizing the directness of the order again. And perhaps most significantly, there's a growing recognition, even within discussions of declarative approaches, that, as one 2017 source put it, declarative implementations have some sort of imperative abstraction layer hidden underneath.
So acknowledging that even declarative systems often rely on imperative actions at some level.
Precisely. Or another 2017 insight, functional programming can build an imperative style, acknowledging that you can use functional techniques to construct sequences of commands, like with monads. This indicates a growing sophistication in understanding these hybrid systems at a finer grain. People are moving beyond just classifying entire languages or entire frameworks as one thing or the other, and are starting to identify the specific parts or layers within those systems that are fundamentally imperative, that are issuing the commands.
That feels like a huge step forward, doesn't it? Being able to dissect a system and say, okay, this part is declarative, setting a goal, but this part here, this is imperative, this is where the state actually gets changed based on a command.
Yeah.
It's like seeing the true underlying mechanics.
It really is. It allows for much more nuanced and accurate analysis. But the battle for clarity isn't entirely over yet. It's not like everyone suddenly flipped a switch.
No. What's the remaining challenge?
Well, the current challenge, it seems, is that many people still instinctively marry this renewed, intuitive understanding of imperative as command to the old, problematic, and deeply ingrained what versus how rule of thumb.
So the old habit persists even with better understanding.
It's an ingrained habit, exactly.
Yeah.
Creates cognitive dissonance. A prime and very current example mentioned in our 2025 source material comes from the world of web development. HTML itself is actively adding a new commands API.
A commands API in HTML.
Yeah, it allows web developers to define custom commands like save document or toggle bold that can be invoked consistently across a web application, maybe triggered by menu items or keyboard shortcuts. This is a powerful, explicit mechanism for telling the browser to do something specific.
Sounds pretty imperative to me. You're commanding the browser.
Right. It seems blindingly obvious you are defining and invoking commands. Yet, astonishingly, some of the early documentation and discussion around this new API still mistakenly refers to it as being declarative.
Seriously. Calling a command API declarative.
Seriously. This vividly illustrates the ongoing battle for definitional clarity. It shows how persistent that old what versus how thinking is, or how deeply the term declarative has become associated with anything perceived as high-level or intent-based, even when the mechanism itself is explicitly command-driven. A command is, by its very nature, grammatically and conceptually imperative. You are telling the system to do something, to perform an action, to change state. There's really no ambiguity there when you go back to the original precise meaning.
Okay, so bringing this all together then, what does this journey, this whole history of precision, dilution, and now maybe reclarification mean for us today, especially with these increasingly complex web applications, frameworks like React or Angular or Vue, which often emphasize a declarative approach? Why should we, as everyday developers, engineers, or even just curious learners, actually care about this seemingly academic debate over a single word's definition?
Yeah, this really raises the crucial so what question, doesn't it? How does all this history connect to your daily work writing code in 2025? Well, the key takeaway is this. Those old, simplistic classifications of entire languages or frameworks as purely imperative versus purely declarative simply aren't good enough anymore. They don't reflect reality. Because nearly every modern language and framework we use is a hybrid, a blend.
Right.
So understanding the true, precise nature of imperative as a specific type of statement, a command that explicitly affects state, helps you make significantly better architectural decisions. It helps you debug more effectively because you know where to look for the actions that change things. And it helps you write cleaner, more maintainable code regardless of the specific language or paradigm you're working in.
How so? How does knowing imperative means command help with architecture, for example?
It's about being able to accurately identify precisely where the commands are in your system, even when they're hidden behind multiple layers of abstraction, like in a reactive framework, or triggered asynchronously by events. This knowledge helps you design systems where, for example, as the source material suggests, all the code controlling a specific feature or piece of state isn't scattered haphazardly across your entire code base. Instead, you can architect things so that the imperative commands related to a specific piece of state are grouped logically, perhaps encapsulated within a specific module or service. It helps you manage the complexity by knowing where the doing actually happens.
So it allows you to pinpoint the action, the locus of change, even in a complex system.
Exactly. It's about being able to precisely target the parts of your code that are directly telling the computer to do something, to change state. And that capability is absolutely crucial for managing the inherent complexity in modern interactive, distributed, and asynchronous systems. It's about moving beyond fuzzy labels and understanding the core actions that drive the system's behavior. #outro.
So, wow. We've really traveled through time on this one, haven't we? From those incredibly precise grammatical definitions of imperative back in the pioneering days of the 1950s.
I mean, it meant exactly command.
Exactly. Then through those decades of conceptual dilution, paradigm shifts, the rise of OOP and functional programming, all leading to widespread confusion.
The era of imperative arrays and the what versus how fog.
Right. All the way to today's landscape, which is still a bit messy, sure, but maybe ultimately hopeful, with signs of a return to clarity. And through it all, the core insight, that undeniable nugget of truth that has somehow persisted through all this evolution and maybe is finally being reclaimed, remains simple and incredibly powerful. Imperative means expressive of a command, period.
It really does boil down to that. Whether it's an old-school assignment statement in AlGOL or a button-click handler in a modern web app that directly manipulates the DOM, or maybe an action dispatched in a complex reactive system like Redux.
Yeah.
If it's telling the computer to do something that changes state, it's fundamentally imperative. It's a direct order being issued.
And this deep dive, I think, really hammers home that point you made earlier from Knuth. Language shapes thought. Vague language inevitably leads to vague thinking.
Absolutely. When our technical terms become imprecise, our understanding suffers, our ability to reason clearly about complex systems is hampered, and communication breaks down. But by reclaiming the original precision of imperative, by remembering its true grammatical root as a command, we gain a much sharper, more powerful lens through which to view, construct, and debug the software we build every day. It clarifies what's actually happening right at the heart of computation.
So maybe the next time you encounter a for loop, or even just a single line of JavaScript that directly modifies the document object model, you'll recognize it not just as, how-to code or procedural stuff, but as a direct command, an explicit instruction being given to the machine right then and there.
Yeah, seeing the command within the code.
Exactly. And having that fundamental clarity, that simple shift in perspective, it can really transform how you read, write, and reason about software. It helps you cut through the layers of jargon and truly understand the fundamental building blocks of modern applications, no matter how many layers of abstraction they might be hiding behind.
And this perhaps leads us to a final provocative thought for you, the listener, to consider. As software becomes ever more interactive, ever more concurrent, ever more distributed, think of microservices, real-time updates, edge computing with commands potentially flying in from countless different sources and affecting shared state in increasingly complex ways. What new grammars, what new linguistic tools or abstractions will we need to invent to help us precisely describe and, more importantly, manage the constantly shifting state of our digital world?
That's a big question.
It is. And perhaps as part of that, will we finally truly shed the inadequate and often misleading what versus how debate for a more accurate, more nuanced language? A language that speaks clearly in terms of intent, state, and, yes, command.
Food for thought indeed. Until next time, keep diving deep.